I think you can hear me now. Is that true? You need to let me know, because my streaming setup is of such nature that I cannot, like, because I'm using my phone as a second camera, you can see here. This is an improvement, but the drawback is that I can't really know if I'm being heard and if the stream is working. So, okay, hello, I think it's working. Nice. Nice. First chat. Hello, Trippy Cat. Nice to have you. Is the music okay and everything? And can you hear me well? And is the keyboard not too loud if I type? I know some people like you know, loud keyboards. So moving on with the plan for the live stream. Whispering. Okay, so so I should be louder. 1 second. Is it better now? I don't know what you mean, but thank you for congratulations. Okay, is it keyboard loud? Okay, so I'll be typing on my other keyboard, don't worry. Or I'll be typing quietly. Nice. So anyways, my volume is really high and I'm going to put it even higher now. Okay. So, moving on. Today's purpose of this live stream. This is an experimental live stream. So, I'm not really sure how it's going to go, but for sure I want to show you that I got the Compute Module 5. Oh shit. You can see it if I lift up the fan, which is now off. It's here, and the bigger board, it's this one. This is the Compute Module 5, right? Okay, and now if you have any questions, just ask them and I will answer. If I can just put my camera here. Okay, and you can see these two like motors. They are connected to the Raspberry Pi and they're supposed to move, right? So today we are going to write some code to make them move, you know. Yeah. Okay, so this is a project for my university. I need to do it. If I don't do it, I'm going to have a problem, so we need to do it as fast as possible. And I don't have a really specific plan. I just need to showcase certain programming skills, and actually also electronic skills are also valued, but you know, the most important thing is a C++. So let me walk you through what I'm actually doing right now. Okay, so assuming you can hear me and everything is working fine, Polish player wishing me everything best. Thank you very much. Okay, so let's maybe do something concrete. Let's maybe begin by powering on the Compute Module 5. I need to actually move a little bit to power it, and you'll see the fan turning on. 1 second. Okay. Okay, I'm glad the stream is good. So now you can see the fan is working, and it needs to be working because the Compute Module 5 by default doesn't have any cooling, so it gets hot really fast and really hot, like even with no load. You know, I have some basic Raspberry Pi OS installed on it, and even if it doesn't compute anything special, it gets really hot really quick. So so yeah, let me now show you how I can connect to it. Basically, I'm going to be using the SSH command, but the thing is, I'm live streaming, so I cannot show the IP. Probably nothing would happen if I showed the IP, right? Because this is a local IP, and even if someone, you know, wants to do something, it's going to be rotated by the ISP. Anyways, just for safety, maybe some of you are extra smart. I connected in a way that you cannot see. Right. And also I need to disable my key capture so you cannot see the password. Right, it's disabled, and now everything should be going well. Maybe you saw the password on the camera. If you did, congratulations. Okay. So you can see we are in. Everything is, you know, we're in the system. Here's the file system. TrippyCat saying, even if your real IP leaked, your router probably blocks everything incoming. I think it would block everything, but I had an episode in my, you know, engineering life that I wanted to host websites through my ISP provided router, and actually you should not do that. But I really wanted to try, so I wouldn't say I succeeded, but I did some stuff with the router, and you know, better to be safe than not to be safe, right? Okay, so we are here, and I already have a GitHub repository in this folder. It's called Stepper Motor Control, and since we're here, let's take a look at wiring Pi. Basically, it's a library that lets you interface with the GPIO pins. KVI3i asking, what is a stepper motor? A stepper motor is a type of electric motor running on DC, and you'll see in a while how it works, right? But in general, it's a kind of motor that doesn't turn continuously, it turns in steps, and you can make the steps really small to the point it looks like it turns continuously, but actually these are steps, right? And the main benefit of that is that you can precisely control its movement, and you'll see it in action in just a second. Okay, so wiring Pi is a library, and when you install it, it comes with a command called GPIO read all. GPIO is the pins you see here. I can connect whatever I want to them, basically, for example, a motor or a motor driver. And if I full screen this, you can see basically a pinout, you could call that, I think. Here's the physical layout. I mean, this column right here is the physical layout of the pins, so how they are laid out in the real world. Their names, of course, and here is the column of the library, how the library numbers them, and here is BCM, which stands for Broadcom, which is the manufacturer of the CPU. And just to reiterate, we are currently inside of the Raspberry Pi, right? This terminal here is me being logged into the Raspberry Pi over the network, right? So that's pretty cool. Right, so here is the GitHub repository, and GitHub is a way of, you know, managing programming projects. So if I run git status, you can see which files have been changed, which files are untracked, etc. And I'm not going to go into the details unless you want me to go into the details. Then I can, you know, say a lot of stuff about it. But let's get to the motors, because that's what I said we'll do. So, okay. Let's maybe get rid of this so we have more space. And I'm going to enable my keylogger, and we can have a demo of the motors, of what I have implemented, because it's really quite, it's not much, but it's honest work, you know. So the green file here is a program, and now I will run it. And I need to be extra special sure that nothing is, you know, connected in a wrong way, because I could damage the entire Raspberry Pi. But everything seems fine. So now when I press enter, the program should run, and what should happen is that it will execute a sequence of steps, which I have in the file commands. These are some of the steps that I programmed, and some of them will get ignored because I didn't implement them yet. But I have implemented I think up and down. And here is a piece of tape so you can see the engine moving in a second. Right, so let's just try, and you should see the diodes of the driver light up. Actually, the chat is a little bit in the way. Okay, now it should be visible. 3, 2, 1, go. Okay. Okay, so I think that was kind of cool. It's not much, you know, but the goal is to also have the lower motor working, this one here, and make it so that the entire assembly can rotate. Do you have any questions so far? Because if you have questions, I'll be happy to answer them. And as you can see here, I'm just going to explain a little bit the syntax that I have invented here. So this is basically analogous to G-codes. And if you don't know about G-codes, G-codes are a standard of communication with machines. Oops. And there should be a list somewhere here. Okay, I know there was a list in the Polish version of the article. So yeah, here's the list. It's in Polish, but you can believe me that, for example, G00 stands for fast movement and tool positioning. G04 stands for like a pause, and etc. And there's multiple. These are not all, right? There are many more. But you know, it's used to control machines, like for example drills, etc. What is that piece that is connected between Pi and robot where the lights blinked? Okay, so this is a good question. Thank you. This is a stepper motor driver. It is a driver, and I would like to show you like a bigger picture of it. Again, it's going to be in Polish, but this basically, I can translate English. Nice. So this is the motor that I'm using. 12, the PLN is basically like $3. So they're really cheap. You can buy yourself some of them. And here you can see 4 diodes, 4 resistors, and basically like 4 wires along with ground, I think, if I'm not mistaken. They're going to the stepper motor. and they let us control each of the coils of the motor separately. So if you Google stepper motor, and if we can see inside, for example here, open, you can see there are coils inside of it, and depending on how you power them in what sequence, you can control the movement of the motor. So you can, for example, make it so that it makes one step. You can tell it to do half steps and even smaller portions called micro steps, right? So that's the basics. Okay. And why do we even need a driver? Why can't I just power it directly from the Raspberry Pi? That's because first of all, motors usually consume quite a lot of power. This is a small amount of power, and maybe it could work with the Raspberry Pi, but they also need 5 volts, and I am not using 5 volts. The Raspberry Pi operates at 3,3 volts. So yeah, I need something that interfaces between these two devices. And basically, to sum it up, the distilled, essence of it is that this okay, one second, so I don't mess up the explanation. Here comes the 5 volts, okay, and they are the power for the coils of the motor, and here from the Raspberry Pi, these cables comes the logic, right? So if the state on the pin is high, it opens up the power going to the engine, to the motor. Can I call it an engine? Is it like correct? I don't know. So I hope that answers your question. And yeah, so we have a working, like, minimal example, nothing special, but it's working. And one thing I wanted to show you is that I can modify the code a little bit using my favorite code editor, NeoVim, and increase the step delay to something like massive. You can probably guess that that will slow down the entire motor, and you are correct. So now let's compile the program a little bit. I mean, not a little bit, actually compile it. Here's the command for compiling. Pretty standard, except you need to add this argument here, telling the compiler that we are using a specific, library. Okay, so now it's compiling, now it's finished, and now if I run it again, we should see the actual, the actual signals displayed on the LED panel here. So it's visible, and now watch what happens. So this is like the slow motion. you know what I mean. It's the same sequence of movements that was happening previously, but it's in slow motion, right? So that's not really useful, but it's educational. So I'm going to stop it right now. And as you can see, now what happens if I stop the program? This isn't a problem for me actually, but I wanted to talk about it. If I stop the program, you can see the LEDs are still lit on, which means that the motor is still receiving power. And that means it's heating up, like the temperature is increasing, which is also not a good thing. Which variable made it slow? I'm going to show you 1 second. I have a variable here, which is just an integer. Now I set it to 2, and it slows down the entire execution because if I read the command up, you can see that here some logic is happening and the coils are powered on, and here you can see the actual line which is causing the delay. It takes as input the step delay variable, which is the amount of milliseconds it will wait between each iteration of the loop, of the for loop. And maybe these variables here are a little bit like cryptic for you. HM stands for horizontal motor, and 1, 2, 3, 4 stands for the 4 pins that are being used to control it. This cable here is connected to the 4 pins. So what I want to do now, actually, if you want to see the code, it is public. You can go to my GitHub, VElectronics. I can paste the URL. 1 second, this isn't it. Repositories, stepper motor control, and it's a really small amount, you know, nothing special. So basically, here you go. I think I can send it like that. Nope. 1 second. How do I? Okay, basically it's github.com/VElectronics, but instead of electronics, it's a free. Okay. Maybe if I expand the chat here. Hello. Nope. Okay, I guess we have to live with it. I'm not going to waste time now. VElectronics with a free /stepper motor control. And everything is public. You can like play with it, etc. You can do whatever you want with it. Okay. XFCS Cisco. I don't know if I pronounced that correctly. Vim plus i3 window manager respect. Thank you for your respect. Actually, this isn't i3, but it's BSPWM. But I guess it's almost the same thing, so whatever. You know. Okay, so let's maybe do something productive, and I'm gonna say that again. If you have any questions, just ask away and I'll be answering them for you. Okay, so maybe I will start off, because I'm fresh and this is quote-unquote dangerous. I will start off by connecting the second motor to the GPIO pins I defined here. So we have the horizontal motor connected, but we also need the more respect, thank you. We have the stepper motor connected, the horizontal one, but now we need the vertical one. Also, I'll move this because it's kind of like was supposed to, you know, be pointing. Okay, I guess it's not going to work, but I guess You know what I mean? Like here's the wiring pin number and here's the physical numbers, and I wanted to make it nice, but it's difficult to have nice things. Okay, let's go. So can you see? I can should I change the camera to like wide angle? I think no need. Anyways, let's for now disconnect the power. Okay, I'm going to break it. I feel it. 1 second. Oh no, if I disconnect the power, I'm going to, the terminal is going to stop working because the entire computer is going to. Okay, so basically this is bad practice. Don't work on powered on circuits, but I can do it. I can. Right, so I need a pinout. Hello. But I need a good one because some of these are like totally unusable. What? No, I didn't want to do that. Okay. I don't want your AI. Okay. Okay. Right. So now I need to like position this in my head. And I'll move it maybe. I can move it here so you can see it. And basically I don't expect you to like see too much of what I'll be doing right now, but okay, so here the physical pin is 37, 5, 3 and 1, so they are all next to each other. 1, 3, 5, 7 or 1, 3, 5, 7. Okay, so I know the fan is connected to 5 volts. That's the 5 volts. On the opposite end is the 39, which is the ground, and I want to connect to these 3 in good order. So maybe I'll have another go at disconnecting the power, maybe. Okay. Power disconnected from the motors, not from the Raspberry Pi. If you have questions, please ask. Okay, so on the driver, I hope you can see. No, you can't see, but it's labeled. There are some super small labels. Which one is which? So if you buy these motors and drivers, you'll have probably no problem working with them. Okay, so let's go. Probably you can't see anything, but don't worry, I'm a professional. Okay. It's hard to reach here. This is the most fun I had on a live stream. Okay, maybe one by one is going to be easier. I was getting ambitious and wanted to connect all of them at once, which isn't a good idea. when I'm done, remind me that I wanted to tell you something about these cards you're seeing on your screen. Okay, I have two of them. Third one and the last one. Okay, so basically I chose the pins all in one place, which is like super stupid. Why those tiny cheap ones are not NEMA 17s, or what is your use case? So basically I have zero experience with stepper motors, so I'm not sure about what are NEMA 17s, but in my case it's it's these ones. Okay, I want to see the NEMA 17s now. Okay, I know them, I think. I basically chose the least expensive, and you know, by the way, hi Vrectek, nice to have you. Nice to have you. Okay, I wanted to tell you about something. You see this thing floating up here. It's nothing important, but I think it's a fun way to, you know, if you have a joke or whatever you want to if you have an idea for something you want to put on my live stream so everyone sees it, you can just tell me, and if it's a fun idea, for example, I don't know, you have a cool graphic, or you have some strong opinions like Windows isn't a good operating system, or NeoVim is better than Neuralink. So, but these are my opinions, okay? But if you have something interesting to put, I can quickly make a like graphic out of it, and we can put it into this carousel up here, and hopefully someone will see it at some point, because they are chosen randomly. How often do you go live? More or less once a week, but it's nothing regular. TMSSEF, you gonna use VHDL? What is VHDL? If I don't know about it, I'll probably... What? Okay, I will not use VHDL. I'm just using plain C++ because that's what I need to use, because it's a university project. But let's go back to the situation here. Okay, so 7531 should be connected to these pins here. So normally I would take the time and check it with a multimeter or oscilloscope just to see if everything is fine. But I'm not going to do that. In general, you have two types of stepper motors, unipolar and bipolar. Yes, that's true. Unipolar uses 5 of 6 wires, bipolar has 4 wires. Yours are unipolar, yes, and unipolar is generally cheaper, easier to control, and slower. Yes, that's true, they are really slow. He isn't going to use VHDL, he is not using any FPGA. That's also correct. And unpolar, unipolar also has less strength. Okay, that's good to know. Okay, up to date. Let's continue. Maybe I can now okay, so basically if I cause a short here, this is going to be a problem, so I'm trying to be really like careful. Because, you know, these PCBs, if they touch each other in the wrong way, this is going to be a problem. So how can I like solve this? Should I tape them? I think I should put tape on them. Any better ideas? With unipolar steppers are very easy to control, just plug in the opposite to 5 volt and then cycle the other pins on or off. Yes, that's what I'm doing actually. Right here. This is the sequence of on and off. Okay, but let's not get too distracted. So I think I connected everything fine. Yes, everything appears to be correct. Maybe try to use an Arduino or similar first. That would be too easy. I mean, I know using a compute module 5 for that is totally overkill, but I am doing this on purpose so I can learn how to use it for my smartphone project. And you know about the smartphone project. I'm basically building a smartphone from scratch. And to do it, I need to be, quite proficient with the Raspberry Pi compute module. So that's why, I'm not really interested in spinning a motor left and right. I'm doing it to get more experience with the Raspberry Pi, running code on it, connecting to it, using the outputs, and so on. And also, it's a school project for my university, so I'm killing multiple birds with one stone. It's 10x engineering right here. Do you use micro-stepping, or why were multiple on at the same time? I don't use micro-stepping. I could use it. I also off-stream used it a little bit just to see. And why are multiple on at the same time? Actually, they are blinking so fast that it appears like they're on at the same time. After you're done with this, could you use a Jetson offloading the compute to the NVIDIA GPU with CUDA kernels? Right, this seems like absolutely massive overkill for two-stepper motors. But why not? Actually, learning about using GPUs would be really cool. For one specific reason, which I did not discuss with you, dear viewers, yet, because I have a project in mind. I need to connect my camera because it's going to die. Okay. I think I would like to build a voice assistant, and when it's already built, I want to expand on it, add sensors, cameras, etc., so it has more, capabilities. And then perhaps I could make a robot that would be smart and funny and sarcastic. Like maybe you saw GPTars on YouTube. Because my problem with like modern robots is that most of them look, creepy. Okay, anyways, let's not get too sidetracked. Final vibe check. Vibe checking. 1, 2, 3, 4. You could also use a stepper driver instead of NVIDIA GPU, but that might be a bit overkill to use a driver. Yeah, I know there are libraries that do everything for you, You don't have to like specify the step sequence. You just run a function, move motor clockwise, and it moves the motor. I'm actually trying to build something that would give me a good grade at school, you know, because just using functions in a sequence wouldn't be really impressive for our teacher. I mean, you gotta train locally the same model DeepSeek uses. This is also very interesting. Very interesting. I also thought about it a little bit. The more I delay my robot project, the better the technology becomes and the easier the project will become. You see, this is like, I'm making progress even by not doing anything. Makes sense, right? Right, okay, let's... So you have already gotten your motor to rotate, if I understand correctly. Yes, at the beginning of the live stream. I'll show you again in a second. Just let me think this through. Okay, everything is fine. Everything's fine. So now I'll run it and we will see if I wasn't too distracted. Just focus on your studies, then this side project will help you later. Of course. Are you an embedded system engineer? I am mostly self-taught. Yes, I am studying mechatronics, but I'm mostly self-taught. I learned electronics doing stuff, like for myself. In theory, mechatronics is a combination of electronics, mechanics, and IT, but right now it's mostly mechanics and math and physics, so there has been zero electronics in my university. So yeah. Anyways, let's go with this. Let's check if everything is working again. I'll power it on. But you didn't answer me. Should I tape the PCBs or what? I can disconnect this. This is a very fun microcontroller which I couldn't use because of conflicts with a certain sponsor who doesn't want me to use them. This is the it's called the Arduino Xiao, I think. It's in English, I mean in Chinese. It's a small version of oh my god, I'm so bad with this. A small version of it runs the same code as Arduino. It's compatible with the libraries, etc. You can use it with the Arduino IDE. It has a USB-C port and it's very small. Look, it's the size of my thumb. So, very cool thing, very cheap. It also comes with, you know, antennas, Wi-Fi, Bluetooth. So yeah, that's just wanted to say that. I'll throw it in my parts box for now, and I think I'm going to tape these PCBs. But if I tape them, then it's going to look like really bad. JK Flaya, hi, hello. We're building a stepper motor robot thingy. I don't even know. Is the chat too big maybe, or too small? Should I move it somewhere? I'll move it here for now. Do you go to university? Yes, I go to university. I study mechatronics currently. Okay. But I learned most of my skills myself, not during my studies. Okay, so let's quit. Let's get the power back. And now the emotional part is connecting, I mean the stressful part, because I'm really scared of breaking the compute module because it's expensive. Okay, this is fine, I guess. Also you can see the coils are energized. That's cool, it means it's working. But if you have a like motor that is sensible to overheating, which mine isn't, that could like cause problems with overheating. Okay, let's plug in the other. Okay, nothing happened, and that's good. That's good. Let's see if the vertical motor is, the vertical one is the one on top. Is it working? So yeah, it's working with the massive delay you can see here. And I can hear it clicking. Okay. So, first of all, I want to make it faster, which I already did here, but I didn't compile it yet. So I'll move the chat away for one now, and let's implement. I have up and down the vertical motor, and I want like similar functions for left and right. Okay. I think I can just copy them entirely. Let me check if I'm not creating any conflicts. Up to date. Yo, which Linux distro and why Arch? Actually, it's Debian, but I used to use Arch. I started off using Arch. So this is Debian 12. Heavily configured. Okay, so here everything is fine. Let's go. Now I wanted to copy this, so let's just take it. This is some peak programming, okay? This is very... Did I already copy it before? Okay, I copied it, but it's not fully correct, so I'm just going to paste over it. And I think now it should automatically format. Yes. But it's a different formatting that I wanted, but I'll leave it alone. Okay, so basically this is fine, and I could optimize this because I'm basically repeating myself here. And here I could write a function. I can do it later. It's not the most important, so right will be clockwise, which is clock sequence, and left I will do counterclockwise, just because I chose these values, not because it makes sense. I just want it to work. I can swap them later if I want. Okay. Okay, so basically, sorry if I'm a little bit awkward with the terminal, but it has a slight delay because it's over SSH, so please pardon my, like, you know, not very smooth code writing. Okay, so I think that's really simple. So these comments are really stupid. I think an AI wrote them for me. So if I now remember the command correctly, percent, was it percent, one second, I have it somewhere. Percent S, okay, percent S. Start from, actually, this is probably inefficient, but okay, never mind, this is stupid. I have a better way to delete them all efficiently. Start. I could make a macro, but I think that would take 20 minutes. So this is peak efficiency right here. And now I want to do the same for move. Let's go, oh no, move. Okay. Boom. 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 Okay. Professors, using a well-made, efficient framework is not impressive, but copying garbage AI code is, of course. Our professor told us that we are allowed to use AI, but when you finish the project, you have to be able to explain everything and answer questions about the code. And some people, you know, use AI, don't understand the code at all, and then, you know, it's a problem because it's not maintainable even by the author, right? So it's kind of stupid. Anyways, I didn't tell you how the program gets the commands. So I have a file here which is called commands.txt, and we can modify it, and the motor will do whatever I, you know, ask it to do. But I don't want to modify it because it's being checked by Git, so I don't need that. So I have left, okay, I have to modify it. Is there another one? No. Okay, whatever. So let's maybe try going left, right, up, down, up, down, up, down. Let's do left, right. So I think that's quite self-explainable, but the left column is the direction. I can do something fancy here, one second. That's not fancy. Okay, whatever. The left column is the direction. I mean the command, so basically direction or sleep. and the right column is the amount of steps or time, so the argument, right? So if I say sleep 1000, it means do nothing for 1 second, and if I say write 300, it means do 300 steps in the right direction. So I think it's super extremely simple. Just use clipper if you're already overcomplicating. Just a joke. I don't know what clipper is. If you don't sleep, does it wait until it is done? What? If you don't sleep, does it wait until it is done? Oh yes, of course it does. It took me some time to understand it. Okay, whatever. It does, yes, of course. We can later try without the sleep. And we're going to test it right now. So I have to compile. Here you go. You cannot tell me VS Code is faster than that. And now I run the program. Okay. I know. It's wrong. I know why it's wrong. Do you know why it's wrong? So you can't run the two motors in parallel. Not yet. But I want to program it so that you can. Okay, so now open question. Viewers, if you know, because the code is wrong, do you know what is wrong with the code? We know the code is wrong. I know where the problem is, and it's really stupid, but do you know? So basically we added the left and right function, and this one is not indented correctly. I can highlight the entire thing like that. I know, you don't have to tell me. So the problem is that I need to change the pin. Here I am using the horizontal motor pins, right? I need to use the vertical ones. The phase, I think the phase is fine. I don't know, maybe it's wrong. But I tested it before, and if I tell it to do one step, it really does one step. So I suspect the phase logic is fine. So I'll replace it with a V for vertical, and okay. Okay, brain problem moment, replace V, okay. And if I jump here, you can see here are the pin numbers. And if you ever have a problem with which pin is which, you know, because the library has different numbering systems, and the physical board has different numbering systems. If you have this problem, you can use, if you're using this library, this command, and it shows you everything. It even shows you the Broadcom, so the manufacturer. But that's not interesting. I mean, it is interesting. Okay, so I'm compiling the program. Now I'm running the program, and we should see both motors move. And let me just, so you can see both drivers. And I suspect it will tangle itself up and like collapse. And yeah, let's go. Yeah, it's working. This is extremely good. Did you see that? Okay, I don't know why I'm so happy, but it made me happy. Vim or NeoVim? GR Fusion. Here I am using NeoVim, but I open it using V. You can see NeoVim, I open it using V because if you're a Linux user, you probably know that you can set aliases for commands. And I can show you that if anyone is interested. In my shell configuration file, I have multiple aliases. And these have been copied from my other system, so most of them will not work. Actually, the weather function is really cool. I need to show you that, but one second. So here you can see, for example, the alias defining V as NeoVim, and Jerzy saying nano only. I mean, I respect your choice, but like, I think it's a bad choice. I can go on a long discussion about why I prefer VI over nano, but it's not the most important thing right now. And did I show any sensitive information to you? I think no. Just some shortcuts for me here. Only Microsoft Word, yes. First thing you do when you open a server, install Microsoft Word and configure the server with Microsoft. Okay, I wanted to show you weather, I don't know, New York. So here you go. Should be correct. This should be the weather in New York. Quite windy, like 56 kilometers per hour. 56 hamburgers per something. I wanted to think of a joke, but my brain is too slow. Okay, whatever. Let's go back on subject. Okay, so this needs to be tiled. Okay. Per bald eagles, yes, that's what I was looking for. Hamburgers per bald eagles, popsicles per hamburger is okay. Why I have a brain issue. Why isn't it working? So this never happened to me, but the terminals aren't working how I want them to work. And here I sent the feed from the camera, so now it goes here. Here you go. Maybe that's better this way. Is it better? But the chat is hidden. If I put the chat here, okay, I think that's really better. Really very better, okay. Linux doesn't work first time ever. Yeah, but it's not my first time. Fix the terminal and the terminal like every Linux user. If I open the fridge, will the temperature in the room go up or down? Extremely good question. Actually, let me think. Because the fridge heats up to cool itself. You know what I mean? If you open it, it goes down, but then later it goes back again. So, interesting take. Okay, I'll think about it. I'll be processing it as a background process in my brain, and then I'll let you know when I come to a conclusion. In the meanwhile, I am going to run the program again because it's fun. Look. This is so good. This is incredible. Yeah, this is so good. How many threads does your brain have? You might need to upgrade. Thank you. Second law of thermodynamic entropy. Hashtag entropy. Okay. So we have two engines working. Now let's actually program something useful. I can commit this. And the rest of the development I'll do on my system, not on the Raspberry Pi, to have a better NeoVim config, whatever. So, Git crash course. How to use Git. I have 3 files that I have modified, and I want to git commit, actually git add all of them. Actually, I don't want to. I want commands to, oh, whatever. Git commit message. What message do we want? Hamburgers per bald eagles. Hamburger. So hamburgers per bald eagles, 4 files change, blah blah blah. Git push enter. Okay. Now is the time that I have to once again disable my key capture. Move the terminal out of your view and log in securely. Don't watch the keyboard. I know you're watching the keyboard. Okay. Okay. So I'm done. That's how you use Git. Probably most of you knew that. So now I can re-enable my screen key. Put it somewhere here, maybe. Yes. Upgrade options for your brain. 2 extra threads model. Z89 till 4 extra. And you use the Polish currency. Interesting. Okay. It's really expensive. Okay, anyways, do you give me permission to use your message as a card? Because, you know, I had the idea that right here I'm displaying some jokes. I don't give you permission. Okay. Also, this fix the terminal and the terminal. This is a good, like, joke. I mean, it's not a joke, but it'd make for a good t-shirt. Okay. Yes, okay, so I pushed it. Now I can like, I don't need this anymore. I'm just going to send it away. And let's go. I'll make this smaller and put it here. If you do use the message, I dare you, I will give you actual advice. So by spelling all my messages badly. Okay, whatever. Let's focus. I appreciate very much your offers, but I need to do the thing. So, stepper. Okay, so here is a better config of NeoVim. You can see I can explore files, whatever. Here I have the code, and I need to pull. Okay, it's pulled. So now I can be more efficient and do something. I don't really know what I want to do. I can make it so that you can control the motors with the keyboard. I can also, oh, okay, I know what I want to do. I think I want to add acceleration. Like a ramp, you know, so the motor accelerates and decelerates at the beginning and the end of this command. What do you think? It's quite simple. You just have to change the step delay. So I can try adding a new variable and call it ramp. Hey, new to your channel. Here, what are you up to? Your mom. I mean, that's your name, and this is not my reply to your message. I am currently programming these motors here to do something more interesting than just turn left and right. I want them to turn left and right with acceleration. And we're just talking about electronics and stuff. So yeah, we're just having fun. You don't need to accelerate when you don't have a speed. This is my speed. This is effectually, literally my speed. If I change it, the speed changes. So let's, I don't know, define it as whatever. And should it be a const? No, it should be variable, I think. Interesting. Okay, I know. It should be const. I don't have time to explain because I'm going to forget my idea. Okay, so let's try to implement it for up. It's negligible. What is negligible? Lol, nice. I have to go kart in what? A go-kart I'm working on. Okay, adding an ECU to it, splicing it up. You have a go-kart, that's so cool. That's very nice. That's very, very nice. It's negligible, the speed. Okay, you mean the thing is super slow. That's true, it could be faster. Curious, what's the use case for this? I am pretty new to steppers. I'm also new to steppers, so that's welcome to the club. The use case is that I want to learn to use the compute module, which is this small SBC here. It's like a Raspberry Pi 5, but it's small. And it's called the compute module 5. I want to learn to use it to be able to use it. It's pretty smart, I know. Okay, and apart from that, it's a project for my university class in programming, so I have to try to come up with some interesting stuff in the code here, because right now it's quite basic, you know, especially like this. Like my friend told me to write a for loop to initiate all the pins, because if you ever have more pins, then you can be more efficient and maintainable and something. And in my opinion, it's quite does make sense, because like I won't have more motors. Like I can't connect an infinite amount of motors, so what's the point in making it scalable? Steppers are not good for go-karts. Maybe they would be good for the steering, you know, not for the main engine, but steering. But steppers are cheap and very precise. They are bad for everything else. Everything else they're bad for? I guess. Depends. What? That's nice. A little struggling to find a Pi that's cheap. Oh, nice. I am freshman for CSSE and I hate Java. We have no C classes or embedded systems classes. Okay, I also don't like Java, and we only have C++ classes. So, yeah, okay. Let's try to cook something up here. By the way, I can add emojis in here in the NeoVim terminal, but whatever. Let's cook something up. I want to predict how many times this loop will run. So it will run, let me think. I need to know where the command is coming from. Okay, so basically this function is executing the list. Okay, so we take in a command, for example, up 50, and then here we would be using the up sequence 50 times, and this would hold the value 50, so where do I want the ramp to begin? I would say 20% of the sequence, so let's add another like parameter. Ramp, how do I call it? Like ramp how do I call it? Ramp. Okay, this is stupid. Ramp, I don't know, like percent, and I'm going to say 20%, and I need to add a good comment because this name is shit. Defines at what point of the we finish and start acceleration. So is that clear? Probably not, but let's continue. Okay, so I need a variable which will tell me at what percentage of the step I'm at. Is what I'm saying like clear, or should I draw it out for you? I can draw it real quick if you want, but I think you'll see when I do it what I meant. Okay, so I want an integer again, or maybe a double. Progress, and this will hold a 0 to 1 value representing command execution progress. That's clear and nice. So okay, but I want it here. And now I want to say that progress equals equals I divided by intarg. Intarg is the amount of times I do the steps, just so you know. As someone who got this same motor to work with Arduino, how complicated did you make this? Actually, not that complicated. You can see it's connected to the driver, and the driver drives the motor, so the electronics isn't that complicated. I'm purposely trying to complicate the code so I get a better the code, right? So I get a better, basically a better better mark for my work, because this is for university, so I need to show off my skills in C++ programming, and I'm not so good at C++, so that's a good learning opportunity for me. However, I forgot to add a semicolon. So is this automatically converting to a... No, it isn't. Or is it? Okay, whatever. I need to convert... I think if I convert one of them to a double, the other will get automatically converted. Yes. JavaScript, bro. I know the basics of JavaScript. I know how to make websites, but I prefer to use Django for websites and use Python instead of JavaScript. Maybe that's weird, but I think JavaScript is just weird. Like, it's a meme, actually. I'll put it here. This is a good spot. Okay. Okay, so now I know the progress, and now I will be modifying the delay. So if the I wanted to just write English. That's what happens when you use Python too much. Okay, if progress is... If progress is smaller than what do I call it? A ramp percent. This is such a bad name. If progress smaller than ramp percent, So first I'm going to try to add the acceleration at the beginning. Ramp percent. Oh, and I want to format this. Okay, watch this. Boom, formatted. Okay, if progress is smaller than the ramp, so we're at the beginning, basically. This means we're at the beginning of the command execution. Then I want to modify the step delay, and now I need to figure out something smart, or at least semi-smart. I would say I want to multiply the step delay by progress and by... Okay, that's a problem because step delay has to be an integer. Okay, so I need to... I need to round it and multiply it by 1000. Yes. So basically I need to... Is the music playing? You didn't tell me the music stopped playing? Are you like trying to sabotage me? Whatever. Round. Okay, this is very nice. Unpopular opinion, JavaScript is bad, Python is worse. I disagree. Like, it's like comparing a hammer to a screwdriver and saying one is better than the other. These are like totally different tools, so you know, you need it's if you're comparing like performance and speed, you know, JavaScript is going to be faster, but if you compare, you know, syntax clarity, Python is going to be better. So you need to compare apples to apples, not apples to bald eagles. Hammer is better than screwdriver. Unpopular opinion. This is also a good thing. I had Python step spacing. Maybe, but it forces you to write at least a little bit clean code, you know. So it has a purpose, but I understand it's a little bit annoying. Okay, this is perfect. Florf. Is this in the math library or? Anyways, I want to copy that so that I have it here. Maybe I can compute that outside. Round step delay florf. Okay, so I need to import CMath. No problem. And I think I can jump between changes like this. Nice, okay. So it's going to be step delay, like the base step delay, which is 2 in this case, times the progress times ramp, how do they call it? Ramp times ramp. Does this make sense? And times 100, let's say. Or what's the point of times 100 when I can modify the ramp here? You know. So this seems fine. Okay, I think I'm done actually. Normally during streams I cannot focus. This looks fine. I can test it in a second. See if the motor moves like I want it to move. So I'm scaling the delay. Okay, first I'm checking if we're at the beginning of the command, right? So here we have progress, and progress is calculated as the I divided by the amount of times we're going to step. So 1 to 0 value. Then I am multiplying the delay by progress and the ramp. So probably the ramp should be called ramp amount. Amount makes more sense. Ramp amount. Okay, I think the best way to find out if it's fine is to test it. Okay, so look at these amazing shortcuts. Stage, commit, the message will be test acceleration, right quit, enter, G push, enter, enter, quit, and now I want a new terminal. And actually I have a terminal already. Hello. This is the second terminal. This is the Raspberry Pi terminal, you can see. And now git pull. Pulled it. Now I want to compile it. Incredible. And let's see. Let's have a look. So what I want to see now is variable speed. Okay, probably you didn't see that, but I think it worked. I just need to tweak the constants a little bit. So let's do that. I think I need to increase the ramp amount so I can actually notice it. Compile and run. Okay, it's slowed down, you can see. So I think I'm like... Okay, that was actually almost perfect. You can see it's really slowing down now. Okay, interesting, interesting. Interesting, so that's a little bit too much. Too much. Also, I'm getting hungry, but that's not a big deal. Okay, so basically it's working, like first try. Is that like I don't know when that happened on my live stream that something worked first time, but that's really nice. That's really nice. What can I do now with this? I can add acceleration to... I can test it on a larger, on different commands, so it's only implemented for the up function, right? So I'm going to delete everything almost and say up 1000 maybe, or let's say 500, so it's easier to like something. And I'm going to go down and let's see. It's working. Lol. LOL. Interesting. Very nice. Very nice. Can I focus on the water? Okay, now you should see it better. Another one. Perfect. Now I need to drink water. I want to use hammer is better than screwdriver as a card here. Here. I think it's funny. Okay, let's reset. Git reset hard. So I don't cause a conflict, and let's go back a little bit. And basically, can you hear me? Everything's fine? I think you can, but just need to know. I think it would be better if I have a separate function for the ramp. Where should I put it? I think I'll put it here. And I'll call it, it's a void function, and I'll call it ramp. And it takes as arguments ramp percent is global, ramp amount is global, and I want to take progress. Right? Yes. Okay. How would you... what is wrong? Okay. Integer progress. Okay. This is annoying. Anyone know how to like disable this? This is annoying. Okay, this is much more elegant. So let's leave it, and I want to also add ramping in the other direction. And I would like to also output, just so I know. Okay, I did something stupid. This should be because this was supposed to be percent. So this should be a float. Actually, I'll make everything a double, just so. And this should be 20%, not 20. Why no one told me? Are you guys sleeping? So now it should be working. And also I want to add another statement. I think I should... Yes, I am sleeping, okay. Are you the only viewer right now? How many viewers do we have? Because I don't have a way to check. I mean, I can check, but I don't want to. You are not viewing. Okay. That's nice. Am I counting as a viewer? So this is for 0 to okay, this is stupid, never mind. No. Progress is greater than 1 minus ramp percent. So in this case that will be from 80 to 100% of the movement. So I want to I'm going to explain it. Let's say I have a movement that goes up. I want to accelerate at the beginning, right? So start slowly, then go to normal speed, and then at the top decelerate. So now I'm working on the deceleration condition. I think it should be step delay plus progress times ramp amount. And here it should be somehow okay, I don't need to have two variables for this. I can just use the same one. Just delete this and take this, put it here. Okay. So now the delay should also increase. It's difficult to imagine that for me. I want to test it. It's going to be faster. Yeah, I forgot I have the different command file because I reset everything. Let's do 20 or 50. Okay, let's see now. So all delays are being set to 2 for some reason. Logic, okay. CPP. So these two functions aren't triggered. Progress. How is progress calculated? Let's output progress. Shall we? So progress is 0? What the fuck? What the hell? Weird. Okay, so I think the problem is that it gets converted to an integer instead of a double. So it's still 0. So the stream turned into ASMR programming. Very nice. Very nice. Okay, so something is overwriting my progress variable. That's a problem. That's a problem. Yes, that's why I'm not progressing. Thank you. You know what? I think I'm going to bring myself some food. And it will become easy after I feed myself. I can bring the camera with me. But there won't be any sound. So how do I do this? How do I do this? Like this. I will send you drone delivery. It just takes 10 years. And drone delivery is really interesting topic. Okay, I'm going away from the microphone and you will witness me cooking soup. I think I'm going to get some soup. So let's try this. Okay. I also won't be seeing chat, so yeah. Okay, so this is. I'm back and the soup has been acquired. This is the weirdest live stream I ever made. But it's also one of the more productive ones. Okay, This is epic. Okay. Make it full screen, help. Why is that thing in the way of my chats? What thing? I don't know. I have a new compositor. I'm using Pcom to composite my windows and do like transparency effects, etc. So it looks nicer. But like I configured it yesterday. It's a fresh thing. Can you hear me, by the way? I see the music stopped. This is terrible. Hold elevator music. Okay. Let's go back from the beginning. The music is in the description, just saying. Okay. So, can you hear me? Is anyone there? If you have any questions, I'll be happy to answer while eating my soup. By the way, do you know Hyperspace? How is he called? Hyperspace something. Pirate, Hyperspace Pirate. He's a really cool YouTuber and he posted today. The video is totally fire. I think you should watch it. Hyperspace Pirate. Yeah, it's really good about wireless power transfer. I really recommend it. You know what Nikola Tesla wanted to do? Basically, I didn't watch it fully because I wanted to do the live stream. Yeah, he's really good. I think he's really good. Oh, I forgot to tell people on Discord that I'm streaming. What? What do you mean? Okay. So my problem was that the progress variable is overwriting, being overwritten. That causes me to not do progress. Okay. I don't know what's so funny to me. I need to focus. Give me 5 minutes. I need to heat the soup back. I mean, heat it more. I'm back. Hello. I don't understand with the teddy bear still. Make it go full screen. You forgot again. I didn't forget. I just figured I didn't want to take the camera. I mean, why is cooking my soup more interesting than electronics and programming? Do we want to do a cooking live stream or something? Okay, let me just tell Discord people that I am currently live streaming. And what is Casio FX? Oh yeah, the calculator. Yes. So if you want to join the Discord, it's open. Just go to my channel description and then you can join. So now I will send a message to everyone. I'm about to mention 40 plus people. Am I sure? I don't know. Yes, I'm sure. Okay. So now, as I eat my soup, I have time to watch my code and find the place where it's not working. I mean, an AI would solve that in like 5 seconds, but let's not do that. Let's chill out a little bit. It's about the I forgot to turn off the short break. It's about the journey, not about the destination, right? Soup is so good. The best soup ever. Okay. So it has to be somewhere here. I mean, it's probably super obvious, but when you're live streaming, it's difficult to see things. Yeah. Progress. Okay, I'm not rounding it down. Should I? Or should I not? Interesting. If I'm eating too loud, you can tell me and I'll not eat so loud. Most useful comment reward 1, 2, 3, 4, 5. What are you even saying? Like, what is going on? What is the bear with the surf riding bike? What is comment reward? Do we want to introduce like comment rewards? Yes, that clarifies everything. What do you mean? Comment reward. Okay, never mind. No, in your code, a comment. Oh, this. Okay. This is actually a useful comment because it shows you how it gets rounded. So it's a good comment. A good one. Okay. I thought it was like sarcasm. Okay, nice. Really nice. Yes, oh, of course my bottom stepper can rotate. Didn't you like watch the stream? Look. Let's do right, I don't know, 300, left 300. Easy. Did you see it? Is the camera fine? Some of the best technology ever. This is really bleeding edge. Okay, this is just sad. This is just... Out of my 69 comments on Twitch, 0 were useful. To me it was funny when you when you did the 100 messages today. Your top commenter. Best commenter award 1, 2, 3, 4, 5. Okay, this is really annoying. Where between these two lines, this one and this one, where do I change the value of progress? Or am I like stupid? What is going on? This is like tragic. My skill is just... Yeah, when I do ramp progress, just like you typed, it goes here. I'm not changing it. But when I output it from the function, I get 0. You saw what I mean? What? While true ramp progress? What do you mean? What do you mean? There's no such thing in my code like while true. There's nothing like that. You're probably like trolling. Very funny. Very funny. No, that will not fix it. It will make it more broken. This is fake news. I feel really stupid now because I'm sure it's super obvious and I just don't see it. Okay, let's ask AI. I know it's kind of sad that I have to do that, but that's life, unfortunately. Hello. This is part of my code. Actually, didn't work. Vim copy be like, because it's on the Raspberry Pi. If I had it somewhere, if I copy it from my normal system, everything will be fine. Look, just have a look. Have a look. Yank, paste, and the problem is that the progress variable outputs 0 when outputted printed from the rump function. Go. Matic says hi, hello, nice to have you. I know. I didn't even have to read it. You need to be more alert, dear chat, because here I have integer. It should be double. So this is a tragedy. This is like some of the most stupid stuff I could have ever cooked up. Yeah, so basically I need to use a better I don't know, configuration of NeoVim, because it didn't even tell me that I'm using, because it's automatically converting. If I used other compiler flags, it would probably catch it. So yeah, JavaScript would not have had this problem. Really? JavaScript is JavaScript has a triple equal operator. This is a problem. There are many problems. Okay, whatever, it's working. It's funny how I got the idea while reading like the first sentence here. Yeah, this is the best, like, you know, this is like terrible, especially for beginners. I like can't imagine trying to learn programming from scratch using JavaScript. You used Svelte, so okay, that's a unique choice. Usually people start off with Python or C++, I think. C++ is too hard as a first language. I don't know, but I know it's hard, I agree, but in Polish schools they start off with C++ usually. Some people start off with Python and that's normal, but usually they start off with C++ because it's closer to the hardware, closer to the memory, you know. So it's hard, but once you learn it, other languages are easier to pick up because they are usually less hard. Insert Balkan meme. Geography nerds. Yeah, we sure have a lot of geography nerds in the chat currently. I also don't understand. There are certain things that I also don't understand. For example, I don't know what, like if I type something and double this syntax with the double semicolons does. I could Google it and probably answer my question in like 30 seconds, but then I forget it a minute later and then I still don't know, so that would be inefficient. I'm an efficient person, okay? I don't learn stuff because I'll forget it anyways. That's how efficiency works. Okay, back on track. I need to focus. Oh my god, this is a massive message. Okay. Okay, because C++ has namespaces, right? Here I have some namespaces. So I'm assigning namespace name. I'm assigning the chrono library namespace to the standard namespace so I can refer to it without having to specify the namespace, right? So this is quite logical, and I hope I won't forget it in like 10 minutes, you know? Okay, I forgot to put this here. This is annoying. Oops. This code here seems stupid because I'm doing the same thing twice, but I'm writing it on purpose this way. I mean this if and this if, because later I will change the delay here, you know. I need a longer sequence so I can see what's going on. Okay. Okay, so now I'm going to output this step delay, and 2 is very fast, and I'll see how it looks. Okay, so it's jumping from 2 to 6. Incredible. Okay, so it's probably another problem with the type of the variable. Yes, ramp amount should be a double, probably. And should this be a double? Is it fine if I do it like this? Oh, it's not fine. Okay. Because it takes an integer. Okay. Okay. Okay, this is promising. Or you cannot see the driver, or this is almost not bad. Let's, for simplicity, change the commands to 100. Okay, now I will be showing off. I want to change 100. Almost. Okay, let's go. That was efficient. That was actually very efficient. Let's have another go. Very interesting. So this will be 0 to 20%, and this should be 80 to 100%. So now it would be nice to have micro stepping, because the resolution of the acceleration thingy is quite low. You can see it's like the delta is 1, which is not too much. I think I can just increase it by increasing this to, let's say, 20, and this I'll leave it for now. Okay, this is more complicated than I anticipated, actually. We have acceleration, but it's like stupid. It doesn't work the way it should be. Because it should be starting from the slower values, not, you know, it's doing the... It's starting fast, then slowing down, and then going full speed, and then... Yeah. Yeah. Getting there, but it's not very easy. Maybe I should invert progress. Just curious. I think I'm dividing by 0 or something. I'm waiting for... Okay. So what I'm doing is, okay, should go here. Okay, this is a mess. Whatever. Okay, this is the total mess, but let's just go with it. So my goal is to have, let's draw a graph maybe. I want to have 0, stable, and then back to 0. This is speed. This is time. And I want the switch to occur like at 20%. So I have the delay, which equals base delay plus progress. Base delay would be 2. Plus progress, so at the beginning that would be 0 times ramp amount, which is 20, okay. So that's the math. So now when I continue, so that would be obviously 2. If I continue, I'm increasing the speed to something. Let's say this becomes 1, then I'm getting 22. Actually, no, it never becomes whatever. Equals 2, 2, right? So .1 times 20 is 2, so that would be 4. I don't see the chat. Yeah, whatever. So I want the delay to increase and stay. Okay, so I want the reverse situation. Okay, the base delay has to be a little bit higher, like, I don't know, 30, and I want to subtract from it. Right. So now when I start off with 20 and I subtract 0 times ramp amount. This is 30, sorry. 0 times 20, okay, so that would be 30. And this would decrease the speed. Oh. Yo. Okay, that's actually good, because now, assuming the progress increases, right? This is progress. This is progress. Assuming the progress increases. Okay, maybe just for clarity, this is step 1 and this is step 2. This would be equal to, okay, this is wrong, 20, that would be 28. So the delay goes down, that means the speed goes up, just like we want, at least in this portion of the graph. So I have to reverse it like I did. Should be fine now. The key was that I forgot or didn't, come to the conclusion that delay is inversely proportional to the speed. So that was my mistake. So this is for acceleration. And now if I want to decelerate, I want the delay to increase. So I would be doing the same thing except 30 plus, and the progress variable would be then close to 1. Okay. So this would probably not be a smooth. Okay, let's think about that later. Step by step. Let's take it step by step. Okay. Let me get back my keyboard. Okay. High voltage, bro. I've watched the stream 5 minutes when it started, then I went out, ate dinner, opened Instagram, slept for an hour, and then opened YouTube, and your stream is still going. Are you sure it is just 2 hours? Or using a mouse to write the notes? I'm using a stylus along with a special tablet thingy. It doesn't have a screen, it's just like a massive mouse pad. Massive touchpad, sort of. The stream is approaching 3 hours, so it's quite a long stream. And the engine is really getting hot here because I left it energized. But that's not a problem. Okay, so we came to the conclusion we want to have minus here. Probably some people would just calculate that in their head, but I don't have such abilities. Let's recompile it and let's go. I want to see smooth acceleration. I assume the deceleration is going to be broken. This is too slow. Okay, this is totally too slow for me to even see if it's working. So let's change it to 10 maybe. 3 times faster. Compile and fire. It's really hard to judge if it's working or not. Okay, it accelerated to 6 and it worked, right? It started off at 10 and accelerated to 6. Which is not the fastest acceleration ever. And it isn't smooth. It's really weird. Let's add another output so I can see if basically so I can see this, and I'm gonna say this is the 20% to 80%. By the way, you decided to go to sleep instead of watching my stream. What is this? What is this? Okay. Okay, I'm getting there. For anyone who doesn't know what I want to achieve, I want to achieve something like this. Okay? I'm getting there. Calm down, everyone. I know it's very emotional. I know. Chat is really stormy. I don't know, I'm saying random words at this point. 3 hours of streaming is a lot. Have you tried to hook things up to an oscilloscope? If you have one, yes, I have an oscilloscope. I have an analog oscilloscope, which is extra cool in my opinion, and I really like to use it, yes. I even have a video, it's called Oscilloscopes in 100 Seconds. It talks about oscilloscopes, and you can see my oscilloscope there. Yes. So what I wanted to do was goes to 6. Okay. Goes to 6 and then jumps to 10. So that's a problem. Use it, bro. I mean, it's not a problem. It's not a problem with the electronics. The electronics are fine. I want to basically make it so that the transition between 0 to 20% is smooth. Because here you can see it's a gap. I want it to be smooth. I mean, you know, no gap. 6, 7, 8, 9, and 10. That's what I want to achieve. And I'm getting there. I'm almost there. Maybe I should have a variable like max speed. Maybe I'll change it later, but for now let's just add more of this and see which way it will go. Okay. So I want less of that. You are right, I'm doing a lot of guessing because I'm kind of tired. I want less, so let's say 10 maybe? 9, 8, okay, this is stupid. So here I want full speed. So progress should not be taken into account. Maybe this. Okay, I think it's time to no. This didn't work. It's inversed again. Is that -10? Okay, okay, that's interesting. Yeah, so this is I need to do it off stream because this is taking too much time. We can do something else. We can do something else, and we are going to go here and perhaps we're going to show you. Do you know about Ranger? Basically, it's a file manager in the terminal. So it's really cool. You use it like with Vim key bindings, and I can, for example, launch programs, etc. I can also preview images in the terminal. Many people think you cannot have images in the terminal, yet it's possible. So yeah, it works. What else? You can set yourself some shortcuts. If you press semicolon, you get these shortcuts. Here I have two of them. One of them is E and the other is G. And E unzips files and G opens GwenView. I don't know why I need that. Because, okay, it crashed. Okay, never mind. So I can open a file here. Here you can see NeoVim displaying Markdown. I mean rendering, and it's sort of rendering it. So yeah, that's what I wanted to show you. What else? Okay, I don't feel like programming now. Harpoon is kind of cool. It's a NeoVim. It's a NeoVim. Okay, I think I'm too tired for that. Neo. I don't know if anyone is even watching this. Okay. Anyways, I think it was a quite interesting live stream, especially the beginning. We got a lot of stuff done. The thingy here was working and I had some fun, so it's the most important. So see you in the next one. I think 3 hours is like the optimal time to